do is, and this is also kind of taken from your book too if you can't see, but you've got widgets and not widgets. And then based on that, you need to determine which are widgets below. Okay, so I'm going to go ahead and have you look at that. I will meanwhile go around and pick up your papers while you're doing that. I'm going to give you probably about a minute, 2 minutes to get that done. So determine which are the widgets, and you better be able to justify your determination. Okay, so let's go ahead and, so what do you think, oh, great, of course. What do you think a widget is?
I don't know, but all the widgets have one claw, or one tail and one eye.
Okay.
And nothing inside.
And there's nothing in them.
Except for
And they're-
color.
Yeah.
They're all
Except for
colored.
Okay, so you said a widget has one claw and one eye,
And the color.
and they're colored in with nothing inside. So based on that determination, which are the widgets? A. B is not a widget because?
Two claws.
2 claws. Okay, C is not a widget because? It's got something inside. D is not a widget because?
No.
No eye. 3 claws. Okay, so far so good? Let's look at the next thing. We're going to talk a little bit about counterexamples. So for those of you people that like to prove other people wrong, you're going to really like this part of the lesson. Okay, a counterexample is an example that shows something to be incorrect. Okay. An example that shows something to be incorrect. That's what a counterexample is. Used a lot in geometry. So let's look at the statement. Everyone knows that a square is a figure with 4 equal sides. I mean, you all know that. But what's wrong with this definition? So what I want you to do is I'm going to give you about 30 seconds to a minute to sketch a counterexample. Okay? And then with that in mind, I want you to write a better definition for a square. So the definition that you're worried about right now, okay, is a square is a figure with 4 equal sides. And you need to figure out if you can draw a figure with 4 equal sides that's not a square. And then come up with a better definition for a square. Okay, so do we have anybody that wants to give it a try? Okay. Alrighty. Let's have you go up with that one.
What's A?
Yeah, that'd be fine. There you go. Okay, like a diamond. Alright. And that's actually has a special name we'll eventually learn. That's called a rhombus. Okay, pretty cool name there. Alright, rhombus. Alright, so the thing is, in geometry, all you do is have to find one counterexample to disprove something. So what would be a better definition for a square? Yeah.
A figure with 4 equal sides and right angles.
Okay. So a figure with 4 equal sides and 4 right angles, that would work. Alright, the interesting thing is actually, what I could say is a square has 4 equal sides and, okay, 4 equal angles. Okay, and that's something that eventually we'll learn as well. Okay, but that would be a better definition. So now with that in mind, what I want you to do is I want you to look up here, and we're going to go through this table as to what are some steps to create a good definition. The first step is to classify your term. So what is it? So notice a square is a 4-sided figure. And eventually we'll even learn that it's a quadrilateral. That's a fancy name for a 4-sided figure. Okay, differentiate your term. How does it differ from others in that class? Okay, that has 4 congruent sides and 4 right angles. And then test your definition by looking for a counterexample. So with that in mind, what I want you to do is look down here below. Okay, the same number of arrow marks indicates that lines are parallel. So notice here I have 2 like little arrows. Okay, that means that these 2 lines are parallel. Notice I have line I is parallel to line J. Remember, we can name a line with a lowercase italicized letter. Okay, notice the symbol means parallel to is kind of like an 11th, but it's closer together. Okay, a small corner, or a small square in the corner of an angle indicates that it's 90 degrees. So all of these are 90 degrees right here. That is what that little square means. And it's important you know these symbols because you will see these again on standardized tests. The symbol, and that's an upside down T, that means perpendicular to. Okay, so notice what this says. Line K is perpendicular to line L. So with that in mind, I want you to come up with 2 definitions. One for parallel lines, one for perpendicular lines. Try and follow the steps to create a good definition. So first of all, classify, differentiate, and then make sure that you can't have a counterexample. So I'm going to give you roughly about 2 minutes right now. Definition of parallel lines, definition of perpendicular lines. Go. And you can work in your groups if you want. It doesn't have to just be individually. Okay, got about a minute to go. So, parallel lines. Somebody tell me their definition? Okay, go.
Two lines that continue forever without crossing.
Two lines that continue forever without crossing. Does anybody have anything else?
They're side by side.
Side by side? Anything else?
They never change direction.
They never change direction. Nobody had anything else? Now, does it just have to be two?
No.
Could you have three parallel lines? Okay, so lines that never meet, or lines that maybe never intersect. Now, we'll eventually look at a more precise definition of this eventually. But for right now, this could be it, lines that never meet. Okay, if the line keeps going on forever and ever, and it never meets, it's got to be parallel. All right, perpendicular lines. Lines that cross each other to form right angles, okay? I'm going to change that word. Intersect. Okay, so lines that intersect to form right angles. And another definition I want you to get down on this page, okay, is skew lines. Skew lines are two non-coplanar lines that do not intersect. And so when we again talk about parallel lines, we'll talk about skew lines as well, because in a way, skew lines can be viewed as parallel, but they really aren't. So that's why we really have to watch our definitions. Okay? Skew lines are two non-coplanar lines that do not intersect. Now, when we think of skew lines, I like to think about a room, okay, something visual. So if I took the line that was in that corner over there by Kelly, so see how that line goes up and down, right? Okay. And then let's say, for example, I took the line that goes along this wall, maybe where it meets the floor. Do you see that those would never intersect? I mean, because this one would keep on going forever and ever. That's just going to go up and down. Those are never going to meet. But the thing is, they're not parallel because they're non-coplanar lines. Okay, see, they're in separate planes. Okay, because remember, a plane would be like this wall, or a plane would be like that wall. So that's what we call skew lines, because technically when we think of parallel, we think of something that looks like this, or something that looks like this. Okay, so anyway. All right, so now on page 49 and 50, you're going to have these investigations that we do throughout the year. Generally, you'll have about one a day. You're going to do this now in your groups. What you're going to do on page 49 and 50, it says, step 1, write a definition for each bold-faced term. Make sure your definitions highlight important differences. Number 2, trade definitions and test each other's definitions. Okay, what I will say is together, if you two want to work on the definition together, you can combine steps 1 and 2. You don't have to each write an individual one. And then when we get done, where is the class going to go through and go through these definitions? So don't put these definitions like in your notes, okay? Because we will actually go through definitions. We're going to see how close you are. But I need definitions for right angle, acute angle, obtuse angle, complementary angle. So on 49 and 50, all of those. You got about 5 minutes, so you're going to have to move pretty quick. Okay?
Do you need to write them down?
Yeah, you need to write them down. But just it should be on a spreadsheet of paper instead of the back of something. The group work that you guys turn in here, then you on the back. Something that's doesn't have to be a white sheet of paper.
The right angle, exactly. Angles on the exactly. Yes. Yes, but we need to do these first. We have to do right angles. cube is smaller than 90.
Yeah, it's even and
Oh, I did too. Angles.
obtuse is
Oh, it's like the other half of the two.
yeah, it's the
The
other.
other half of the.
But there's two angles that add up to 180 degrees.
Angle that is less than 90 degrees.
Vertically. You're the same angle.
They're like the same.
Yeah.
Okay, I'm going to give you about another minute to finish.
So these are not obtuse. Yeah, it's not vertical. Something in sense.
Do you want us to do all of us or just those?
Is it the
Those are in the book, 4950.
Is it blue and silver or something?
So
Is
compliment.
it like blue and silver? She's like. Oh yes.
Mustaches.
She lines hers up too.
And I have made it so it looks like it's one.
She said it took her like 5 minutes to line them up like that. It took me like an hour just to cover it and not look terrible.
They're out of work here.
I did it last night at like 10:30 and it was after I did all.
Except you don't get very much because it's like, then it didn't roll over. Yeah, I still like yeah, I didn't really want to use all
I
of
had
it.
quite a bit left if I didn't make 3 layers.
Okay, so let's go ahead and talk about what's a right angle. And you probably want to get these down because these are the definitions we're going to use. What is a right angle?
Angle that is exactly 90 degrees.
It's an angle, okay, evidently we're having trouble here. An angle that measures 90 degrees. So hopefully you got that. It's just an angle that measures 90 degrees. Okay. What's an acute angle?
An angle less than 90 degrees.
An angle that measures less than 90 degrees. Okay. It's an angle that measures less than 90 degrees. Okay. Sorry, I'm trying to get rid of that so that it shows a little bit better. There we go, we'll do that. Now it'll work fine. Maybe not. Okay, what's an obtuse angle? An angle that measures more than 90, but what? Less than 180. Okay, so an obtuse angle is an angle that measures more than 90, but less than 180. So when you think about obtuse, you think about big. Okay. Acute, you think, oh, that's little, that's cute. Okay, but obtuse is big. Alrighty. Complementary angles and supplementary angles. These two are ones that you need to get straight right away from the get-go. Okay, complementary angles, what can you tell me about them? Two angles that add to 90 degrees. What are supplementary?
180.
Two angles that add to 180. Now the question is, how do you keep them straight? Because you know one's 90, one's 180. This is the way you keep them straight. I always think about it alphabetically. You have complementary, which is C, S, which is supplementary. Alphabetically, complementary comes first. Numerically, 90 comes first. Okay, supplementary. S comes alphabetically last. 180 is the biggest of the two. So, I mean, if that works for you, great. If it doesn't, find another way. But somehow remember, complementary, two angles that add to 90, supplementary, two angles that add to 180. Vertical angles. This will be interesting. What'd you get?
Angles that cross in the middle.
Angles that cross the middle. Somebody else have anything? What you got? What do you have?
Angles that have equal measure that are opposite.
Angles that have equal measure. Good, because that is true. Okay, here is the formal definition. Angles formed by two intersecting lines that share a common vertex, but no common side. So this is the textbook definition of a vertical angle. A lot of people just say they're angles opposite each other. Okay, but they are two angles formed by two intersecting lines. They share a common vertex, but no common side. What about a linear pair? Two angles that add to 180 and share a common vertex and a common side. Two angles that add to 180 and share a common vertex and a common side. Now, as you're finishing that up on today's homework, you're going to have some true and false questions towards the end. You need to think if you can find a counterexample. If you can find a counterexample, that's going to make the statement false. If you can't, that's going to make the statement true. So your assignment then for tomorrow, pages 51 through 52, it's 1 through 24. It's a lot of fill-in-the-blank, true-false questions. Okay, it's also drawing. The first 8 you have to draw. Biggest thing you need to know here, indicate right angles, indicate parallel lines, indicate congruent segments, and congruent angles. So make sure that the tick marks are shown.